Okay, so today we're going to be talking about integers mod n. So we're going to be looking at the definition. For every integers n greater than or equal to 2, the integers mod n denoted z mod n is a set of the n distinct congruence classes of z modulo n. So we're going to look at an example. So here I have z mod 6, and so we have, in z mod 6, in any integers mod n, we're always going to be working with the set n minus 1, or our set will only consist of numbers n minus 1. So since we're working with 6, 6 minus 1 is 5, so we're only going to work up to, or consist of numbers up to 5, 0, 1, 2, 3, 4, and 5. And we're going to be looking at two binary operations, the addition and multiplication. So first we're going to make an addition table for z mod 6. So we're going to have our elements 0, 1, 2, 3, 4, and 5. Likewise, on the other side, we're going to have the same numbers. And when you're working with these, you just want to be careful and make sure that you take your time, because it can be really easy to make a mistake. I do them all the time. And also, you do want to make sure that you're computing these row by column. So that's also very important. So starting with 0, we're going to get 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4, and 0 plus 5 is 5. Then we're going to do 1, 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is going to give us 5, and then 1 plus 5 is going to give us 6. And we notice that 6 mod 6 is 0 because we don't have a remainder. So with 2, 2 plus 0 is 2, 2 plus 1 is going to give us 3, 2 plus 2 is going to give us 4. 2 plus 3 is 5. 2 plus 4 is going to give us 6. But again, since we are working with z mod 6, 6 mod 6, we don't have a remainder. So let's try to make that look more like a 0. There we go. 2 plus 5 is 7, and when we do 7 mod 6, we get a remainder of 1. Now 3. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is not 0, it's going to be 5. So like I said, just take your time with these. 3 plus 2 is 5. 3 plus 3 is going to give us 6. 6 mod 6 is 0. 3 plus 4 is going to give us 7. But then we remember that we're working in z mod 6, and 7 mod 6 is going to give us a remainder of 1. 3 plus 5 is going to give us 8, and 8 mod 6 is 2. So now we can work with 4. 4 plus 0 is 4. 4 plus 1 is going to give us 5. 4 plus 2 is 6. 6 mod 6 is 0. 4 plus 3 is 7. That gives us 1. 4 plus 4 is 8. That gives us 2. And then 4 plus 5 is 9. 9 mod 6 gives us a remainder of 3. So with 5, we're just going to kind of work out the same way. We're just doing row by column. 5 plus 4 is 9, 9 mod 6 is 3. Then 5 plus 5 is 10, and 10 mod 6 is going to give us 4. So it's not that bad, just, like I said, take your time. And we also have a multiplication, we can make a multiplication table for z mod 6. I'm not actually going to write the whole thing out, just so that we don't waste too much time on that, but I do want to show you guys. So, I just already have it here. So here we go. Again, we have 0 through 5 going across and going down. And this works the same way, row by column. So if you notice for the 0 row, there's just a bunch of zeros because 0 times anything is 0. And same with the column coming down from 0. 0 times anything is just 0. So that's why we have zeros there. And it just works the same way. We're gonna get the same elements like 0 through 5, but they're just gonna be in different spots since we're not working with addition. For example, like if we do 3 times 3, right? We'll get 3 times 3 is 9. 9 mod 6 is 3 though. However, if you looked at 3 plus 3 on the addition table, you do not have that value. So that's just a little difference. Yeah, so now we're going to be looking at the zero divisors of Z mod 6. So let's look at that definition. A non-zero element A in Z mod n is a zero divisor in Z mod n if there is a non-zero element B in Z mod n so that A times B equals 0. So let's go back to our first example. Let's try to find the zero divisors of Z mod 6. So let's just scroll down a little bit so that we have room. And again, I think an easy way to think of zero divisors is just kind of, if you think of the GCD between both numbers, between numbers A and B, not being 1. So in Z mod 6, if we're looking at the numbers 0, 1, 2, 3, 4, and 5, which one of those numbers don't have the GCD of 1 when you're comparing it with 6? So the first one we would have to say is a 2. Just trying to make that look like a 2. Because 2 and 6 do share a common factor, right? It's 2. So next one would be 3. 3 and 6 share a common factor, which is 3. And the last one is going to be 4, because 4 and 6 also share a common factor, which is 2. So these 3 are my zero divisors when it comes to being in the set of Z mod 6. So let's jump to our first concept check. So it says find all the zero divisors of Z mod 26. So feel free to pause the video, try to answer it, and come back to it when you're ready. Okay, so when we're working in Z mod 26, again, you want to look at numbers that have that share, common factor with Z for 26. So if you chose A, that is absolutely the correct answer. All those numbers do share a common factor. If we look at B, that's not going to be the answer because those are actually the units, which we're going to get into in just a sec. And then option C looks very tempting. The only problem here is that 0 is included in there, and 0 can actually never be considered a zero divisor. We're never going to be thinking that as a zero divisor. And also we have the number 26. Since we're working in Z mod 26, our set does not consist of number 26. It only consists up to the number 25. So A would be our answer. Next, we're going to be looking at what a unit is. So the definition states, an element x in Z of n is a unit in Z of n, Z mod n, if there is an element y in Z mod n such that x times y equals 1. In this case, the element y is called the multiplicative inverse of x. We're going to get into that second part of the definition towards the end of the video. Right now, let's just pay attention to what a unit is. So again, working in Z mod 6, an easy way to think of the unit is if the GCD between the numbers is 1. So basically, that number and 6 don't share a common factor. So our units would have to be 1. 1 is actually always going to be considered a unit when working with integers mod n. And then the other one would have to be 5, because 5 and 6 don't share a common factor. And 1 does not count. So those would have to be the units when it comes to Z mod 6. So now we're going to look at our second concept checked. So it says find all the units of Z mod n. So again, feel free to pause the video, try to answer it, and then come back when you're ready. Alright, so if you guys chose the answer B, that is definitely correct. B is going to be our answer. These are all the units, 1, 2, 4, 5, 7, 8. Do not share any common factors when it comes to the number 9. If you were thinking A, those are actually the 0 divisors, right? So in Z mod 9, those are going to be the 0 divisors. And then in C, it looks just like B, except what? It has the number 9 inside. And our set doesn't even include the number 9, because remember, we're in integers mod n, we only work up with n minus 1. So, alright, so next we're going to be looking at the multiplicative inverse. So, just putting back the definition. So, it's the element y when x times y equals 1. So, let's look at an example. So, if we're trying to find the multiplicative inverse of 3 mod 5. Again, just like the definition where we said x times y equals 1, y would be the multiplicative inverse. So in this case, if we have 3 mod 5, and we're multiplying it by this something, right? We can call it y. I'm just going to leave it blank here. Something mod 5. And we want that to equal 1. Well, thankfully we're working with a small set, so it's not that hard to test the numbers out. But since we are working with mod 5, we're just thinking of 0, 1, 2, 3, and 4. And, well, the only number that could be here is 2. Why? Well, if we do 3 mod 5 times 2 mod 5, that's going to give us 6 mod 5. And when we work out 6 mod 5, that's going to give us 1. So this is where, so your multiplicative inverse would be considered 2. And that's of 3 mod 5. So that checks out. That wasn't so bad. That was actually pretty fun. So now we're going to go to our third concept check. So find the multiplicative inverse of 8 mod 17 of the element 8 mod 17 and z mod 17. So take a minute to pause the video, come back when you're ready. And if you chose answer C, you are definitely correct. This one was a little bit of a toughie just because we are working in a way larger set. We're working up in 17, so B and A are not going to be your correct choices. And it's really, I can see why you would choose option A, but here I'm going to show you guys how we get our answer. So before, in chapters before, we could actually solve these by writing them as a linear combination. So that's what I did here because we're working with 8 mod 17. So if we do 8 times 2 plus 17 times y, it almost looks like it's going to give us 1 because we get 16 plus 17, but that's not actually true. That 2 is negative. And that plays a huge role when we're trying to solve this. So because we get negative 2, we actually have negative 2 mod 17, not just 2 mod 17. So in order to solve negative 2 mod 17, you can just add those two numbers, negative 2 plus 17, and you're going to get our answer. So we're going to get 15 mod 17, which is what works. So 15 is going to be the multiplicative inverse. And that's it for this video. I'm glad that's all I have for you guys. Thank you guys for watching. And just like I said, take your time when you're computing these and always have fun with them.